In this video, we're going to look at the 6.4 notes. You should all have been given the half-sheet handout in class, which has this template. We're just going to be filling in some examples of these properties. If you weren't given one of the handouts, then I'd like you to go ahead and just copy down these examples in your notes, and then we'll fill in the examples. So we're going to talk about the properties of rational exponents. Remember, rational number is just a number that can be expressed as a ratio, and ratio just means fraction. So this just means that the exponents in our equations may not always be whole numbers. They may be fractions, and we want to be able to deal with those. We're only going to be looking at two properties of exponents that may be extremely new for you. The rest of it should be recall. You should have seen these exponent properties before, and some of them I know you are very familiar with. We're just going to be using them with fractions instead of just whole numbers. So the first one we're going to look at is one of the ones that is new for you. We have b to the m over n, and up here in the directions it does say m and n represent rational numbers, so those are fractions, and we're going to assume that none of the denominators is equal to the number 0. So we're not going to assume that any of these are trying to divide by 0. So in this situation, we have b to the m over n. And what that means, what a fraction exponent means, is that we are going to be raising b to the m power. So it's raised to the m power. So whatever number's in the numerator, that's the number that we are raising this to. And the denominator, this n value, that's what we're rooting it to. So the b to the m over n means that we raise it to the m power, and we root it to the n power. And it doesn't matter which one happens first. So you'll notice it equals the nth root of b to the m, so we'd raise it to the m power first and then do the nth root. Or we could do the nth root first and then raise it to the m power. We're going to get the same answer either way. So let's go ahead and take a look at an example of this with numbers. So let's say I have x to the 3 over 5 power. That means that the 3 is in the numerator, so that's what I'm raising x to. That's the exponent of x. And the 5 in the denominator, that's the root. So I'm going to be taking the 5th root of x to the 3rd power. Now remember, either one of those could happen first, so it could also be expressed as the 5th root of x raised to the 3rd power. Either way, it's exactly the same. So I want to go ahead and get two examples in our notes of this. Our first example is going to be example A, and it can go right here in between these two situations. This example is going to be x to the 1/2 power, because we're going to be seeing that a lot, especially as you go forward in math. X to the 1/2 power means that I'm raising x to the 1st power, and that denominator 2 means that I'm taking the 2nd root. Now we don't usually write the 2 when we write a 2nd root, it's just the square root. So x to the 1/2 power means the square root of x. They mean the exact same thing. So let's go ahead and take a look at our second example of this. This is example B, and again we can write it right down here in between. In example B, we're taking the square root of a times b. So if we're taking the square root of a times b, if I want to write that in exponential form, it means that I'm taking this a and b, and I can write what power they're being raised to. Inside this radical, each one of these is being raised to the 1st power. So they're being raised to the 1st power. And that square root means the 2nd root, which means I have the 2 in the denominator. So this is a and b to the 1/2 power. So what this really boils down to is that the 1/2 power means the square root, and they are synonymous. They go back and forth. So if we wanted to write it in radical form, it would be like example A. If we wanted to write it in exponential form, we'd be converting it like example B. All right, let's go ahead and take a look at our next scenario. Our next scenario, again, may be one that's brand new for you. So let's look at b to the negative m power. This is when we start getting into negative exponents, and it has a very specific meaning. It means that the b to the m power is actually supposed to be on the other side of a fraction. So whichever side of the fraction it's on right now, it needs to go to the other side. So sometimes I think of the negative symbol as a little fraction symbol. It makes me remember that this b to the m power is happening in a fraction. So right now, this b to the negative m is in the numerator of a fraction. It's over an invisible 1. So the negative just tells me that it needs to go upside down. So the b to the m power needs to be in the denominator of this fraction. And in this case, there would be nothing left in the numerator, so we'd put a 1 as a placeholder. So let's go ahead and take a look at an example with some variables in here. So let's take a look at x to the negative 2 power. So the negative, again, is a little fraction bar, and it reminds me that this is actually supposed to be a fraction, and in this case, my x to the second power should be in the denominator of a fraction. So the x to the second power should be in the denominator. And there's nothing left in the numerator, so we can put a 1 as a placeholder. So we basically just flip it upside down. But the negative just tells me that whatever variable I have to whatever exponent should be on the other side of a fraction, and it can look a little bit different. So let's go ahead and look at what we're going to call example C right here. And we're going to take this number 2 over x to the negative 1/2. 2 over x to the negative 1/2. Remember, that negative just tells me that it should be on the other side of a fraction, and this time I already have a fraction. So the other side is actually going to be the top. If it's already in the numerator, we bring it to the denominator. In this case, it's already in the denominator. We're going to move it to the top. Now, there is already a 2 in the numerator, so it's just going to go with the 2. So the 2 will stay on top, and my x to the 1/2 power will go and join the 2 in the numerator. There's going to be nothing left in the denominator, so we could put over 1, or because we're in math class, we always simplify that over 1 to just become invisible. So we don't actually have to put that part at all. So it's just 2 times x to the 1/2 power. So the negative just made me move the x to the 1/2 power to the other side of my fraction. We've got one last example of this. We're going to call this example D. In example D, we have x to the negative 1/2 power, and this time it's over 2. So x to the negative 1/2 power over 2. And this is an exponent. I'm going to rewrite it just so it's a little clearer. It's going to be the same equation, but this is x to the negative 1/2 power. All right, so this x to the negative 1/2 power, again, that negative for the 1/2 just tells me that that x to the 1/2 should be in the denominator. So there's already a 2 in the denominator. It will stay in the denominator, and the x to the 1/2 will go down there to join it. And this time we'll have nothing left in the numerator, so we're going to go ahead and just put a 1 as a placeholder. Okay? All right. So those are our two brand new situations, both fraction exponents where the numerator is the power, the denominator is the root. And for the next case, if I have a negative exponent, it just tells me that my variable to that same exponent should just be in the other side of a fraction. Now, the rest of these are going to be very familiar, and it works the same way with numbers that it does with fractions. So for our next situation, we have b to the m times b to the n. If I'm multiplying those together, I add the exponents, just like usual. And it doesn't matter that sometimes they're fractions, I just add the fractions. So in this example, we have x to the 1/2 times x to the 3/2. In this case, I would just add those exponents when I multiply my x's. So this would be x to the 1/2 plus 3/2, which would just be x to the 4/2. Now, x to the 4/2 can be simplified. So x to the 4/2 just equals x to the second power. 4 divided by 2 is just 2. And that's it. So just like usual, if I'm multiplying my variables, we multiply the bases, we add the exponents together. Let's go ahead and take a look at when I'm dividing my variables. So these have like bases. I'm going to go ahead and divide my variables. That just means that I'm going to subtract my exponents. Just like we're used to with other variables with whole number exponents. Let's say I have x to the 5/2 divided by x to the 3/2. All I have to do, it's the 3/2, all I have to do is subtract those exponents. So x to the 5/2 minus 3/2. Those have a common denominator of 2, so I can just subtract 5 minus 3, which is 2. So that's x to the 2/2, which again I can simplify. X to the 2/2 is just x to the first power, which is just x. So we just subtract the exponents like usual. We've got a couple more cases to look at here. Up next is b to the m power raised to the nth power. So we're raising a power to another power. And just like usual, all I have to do when I'm raising a power to a power is multiply my two exponents together, because this says I have n times whatever exponents I started with. So b to the m to the nth power is just b to the m times n. So let's see that with some variables in here. So let's say I have x to the 1/2 power, and I want to multiply that by the 3/2 power. Now, we can make this happen because all I have to do is take my exponents and multiply them. So this time I have the 1/2 power times the 3/2 power, which all together, if I multiply those exponents together, 1 times 3 is 3. Oops, let's write this as the exponent of an x here. X, as a pen please. There we go. All right, 1 times 3 is 3, and my denominator, 2 times 2 is 4, x to the 3/4 power. That's what we would be left with. If we want a quick refresher, if I wanted to put that in radical form, just for funsies, which we just learned in our first example, radical form, the 3 in the numerator means the exponent x is being raised to, and the 4 in the denominator means the root that we are rooting x to. We could also root it first, and then raise it to the 3rd power. This was just for fun. Fun for me, not fun for you. It might be fun for you. I hope it's fun for you. But I just wanted to remind you that if I'm writing something in radical form, the numerator is the exponent and the denominator is the index. It's the root. Okay, so we have 2 more examples here. This next one is ab to the m power, which is a to the m power and b to the m power. So I can distribute my exponents. If I have a monomial, I can just take the exponent of each term one at a time. So if I have ab to the m power, I can do a to the m and b to the m. Now we've actually already seen this with rational exponents. You just aren't aware of it. So let's take a look at our example, and then we'll write it in some terms that should be more familiar to you. So my example of this is, what if I have x, y, and I want to raise that to the 1/2 power? In this case, because I can distribute my exponent to a monomial, I can have x to the 1/2 power times y to the 1/2 power. And this is a property that you guys already know about. You've seen this before. You just haven't seen it written with the 1/2 power. So remember, from our second example, the 1/2 power means the second root. Oh, I'm sorry, it's still from our first example. Just like example A and example B, the 1/2 power means the square root. So this basically is just saying that, we're going to recall this, that the second root of x times y, the square root of x times y, is the square root of x times the square root of y. And we've been using this principle. We've usually been using it to go the other way. We say if I have the square root of x and I multiply it by the square root of y, then I can put them under one giant radical and just square root both of them together. So we've been using this property. You guys just didn't know that it had this crazy notation. And we have one more that we've already been using that I want to make sure you guys know how to use, and that's this last one here. A over b to the m power, we can distribute the exponent to the a value and the b value. So if I try to do that here with my exponents, if I have x over y to the 1/2 power, we'll just use 1/2 because we're most comfortable with it, I can distribute that 1/2 to the x value and to the y value. So x to the 1/2 over y to the 1/2. And again, we've actually already used this principle. You guys just didn't realize that it was an exponent form. We've used it in radical form. So again, we're going to recall one more time, and we're going to take a look at using this with radical notation. So xy to the 1/2 power, x over y to the 1/2 power, is the same thing as x over y to the first power and the second root. So that's just the square root of x over y. And we already know that if I have the square root of an entire fraction, I can break it up into a top and the square root of the bottom. Or I can go backward. If I have the square root of x over the square root of y, because they're both the second root, I can put them in one giant square root and end up right back here where I started. So these are some notes for the notation of these principles, and we're going to be using these principles in an activity.